Hello, welcome to Channel 9 Live here at Microsoft Ignite in Chicago. My name is Matt McSpirit, technical evangelist for all things in the data center. Now before we start, don't forget you can always interact with us through a couple of means. On Twitter with hashtag MSIgniteCH9, but also if you prefer to fill out good old-fashioned forms, go to channel9.msdn.com, fill out the form under the video and you can interact with us while we are live. So don't forget. Now, this morning, I'm joined by what can only be described as a storage dream team. Sid, Jose, from our high availability and storage group at Microsoft. Guys, welcome. Thank you for joining us. I'm sure people at home appreciate it.
Thanks.
I've been monitoring Twitter for the last couple of days since the keynote announced and as the sessions and the overview sessions have been going on. And I'm hearing a lot about some of the amazing storage innovations that are being introduced in the next release of the platform.
Yep.
But before we go and talk about what's coming next, bring people up to speed for those who perhaps don't know, just how we've got to this point in terms of storage in the infrastructure.
So if you look at storage, we started the journey back in 2012, and then we made that the second phase of the journey with 2012 R2. So we introduced what we call software-defined storage back in 2012. So let me step back before that. In circa 2008, the only way you could have a storage for a SQL Server or a Hyper-V cluster would be a traditional SAN storage, right? iSCSI or fiber channel, and that works great. And we looked at how we can basically provide alternative methods of storage, and we introduced what we call the scale-out file server, connected basically, which gives you the ability to store VHD files on a very performant, tolerant, fault-tolerant, and SMB file share.
Okay.
It's kind of unthinkable. Before that, putting your VHD or SQL Server database on SMB share was kind of unthinkable. Hey, will this be able to serve this up? It's mission critical. So we kind of looked at what it takes to, make that VHD highly available, highly performant. If everything fails, the VHD is still available. And how do you make that scale out, right? Okay. As you add more file server nodes, you can basically add more bandwidth. And behind that file server, we had what we call the storage spaces shared JBOD, where you had resilient, highly available storage on standard disk drives, SATA drives, SAS drives at the time. So we kind of made that first part of the journey, and we kind of introduced a lot of things around deduplication, tiering, write-back cache. We did a lot of the goodness there. Maybe Jose wants to add some more.
And a key piece is that throughout that work, right, we always had this resiliency in mind. So we always had multiple disks, any disk could fail. You had multiple enclosures, any enclosure could fail. Multiple nodes, multiple network interfaces. So the high availability was always in our mind, but that also buys us some performance. So if you have two NICs at 10 gig, we actually gave you 20. So we would aggregate. If you have multiple disks, we aggregate performance as well. So it's a performance play as well as an availability play.
So there's a lot going on there from 2012 to 2012 R2, new capabilities. You mentioned Spaces.
Yep.
Some people may not be familiar what Spaces is all about. So explain to us in a bit more depth what Spaces is specifically.
Yeah. So happy to. So storage Spaces, what it basically does, it takes a bunch of drives. Okay, it could be across multiple disk enclosures, and it basically virtualizes them and gives you a highly available, resilient pool.
Okay.
So if one drive or multiple drives fail, the system still continues to operate, basically. Okay. So that's essentially what it does. It has all the attributes of reliability and resiliency built into the system.
Right.
And the intelligence of what used to be in PCI rate controllers or hardware rate controllers is pretty much in the software now.
Okay.
And one of the things I should kind of point out is basically when we looked at the whole 2012 R2 software-defined storage stack, we use that stack in our converged infrastructure, what we call the cloud platform system. That's where you have compute, network, and storage. And we have the 4x4 configuration, as we call it, 4 scale-out file servers with 4 JBODs. And that's used and deployed at scale through our cloud platform system. And that runs multiple workloads like, SharePoint, large SQL, small SQL, a bunch of other, Microsoft workloads and others. So it is vetted at scale, at very large scale, and basically with a lot of scenarios coming together. So we feel good about it.
So architecturally and as a process for somebody setting up a Spaces-based infrastructure for the first time, you mentioned before JBOD. So you've got your JBOD, which is filled with just hard disk drives, magnetic, or is there?
Yeah.
Can we fill those JBODs with a mix of disks?
Yeah,
you can actually mix them, and some folks actually even do an all SSD configuration. But the most common thing we see is we have a few HDDs, spinning disks for capacity, and a few SSDs for performance.
Right.
And you combine the two, and Spaces has the ability to move the data that is hot to the right tier, so you get the most out of the two tiers that you define. So that is part of what we introduced in 2012 R2 to kind of give the performance boost that we get from SSDs. SSDs obviously are hot right now.
Yeah. So now you've got your JBOD, you've got a mix of disks, you've connected it via industry standard SAS. Are the servers that we're using as scale-out file servers, are they any specialized in any way, or can you use pretty much any x86-based server? Can we be flexible?
It is essentially a standard x86 server, but what we do is be very specific on the reference profile, if you will, for the file server nodes. Because if you realize, and Jose can talk a little more about that, if you realize how the Hyper-V cluster is asking for the VHD, and that data transfer is happening on what we call SMB direct, right? It's basically on a low latency network, so we kind of bypass the TCP traffic. So end-to-end, if you see, it needs very prescriptive guidance on what kind of SAS HBA to use, what kind of RDMA adapter to use, how much memory, what type of hard drives, and a lot of the learnings from our cloud platform system, we kind of injected that back. And what we see is in the early days of software-defined storage, this is across the industry, we believe that putting the software-defined storage stack along with a very prescriptive hardware guardrail configuration is the best thing to do for customers, as opposed to customers trying to figure this out and kind of putting everything on their own. Yeah. So it needs to be pre-tested as a appliance, virtual appliance, and a physical appliance.
Yeah, and there are a multitude of partners who are deploying, shipping configurations that are scale-out file server nodes of various sizes combined with
and the key there is balance, right? You want to create a configuration that gives you great performance, that and has a balanced networking tier, storage tier, and the file servers themselves. There was a great session at Ignite yesterday here by Joshua and Jason that were actually explaining how you configure, how to create a balanced configuration. And they have a spreadsheet they're working on that you can just plug in your numbers, and they'll say, oh, you're good for a 3x3, like 3 servers, 3 closures, with this many SSDs, and you create your volumes of this size. And the goal there is to actually spit out the PowerShell that would go and configure the system for you.
Nice. Those guys have been busy.
Yeah, and that's great stuff because people have lots of questions, right? How large can the pool be, and how many disks can I put together here? And there are many different types of enclosures. So they are kind of making this very straightforward with some automation and a spreadsheet.
Excellent.
And Excel is great.
I would just add one more thing. I mean, if you see, Dell is a great partner. We have a lot of partners in the scale-out file server and the enclosures. We have Dell, HP, Dataon, Rating. If you go by the booth here, you will see in the Dell booth, they have the very prescriptive scale-out file server and Spaces configurations. Depending on the workload you will have, be it VDI, or be it SharePoint, be it SQL. So basically, go and check it out, and I would ask people to check it out and kind of get some information there.
Absolutely. So if we continue going up that architectural stack, we've got our JBOD, we've connected it via SAS, we've got our scale-out file server nodes. We've got flexibility to add additional nodes if we need to scale out that way, or add additional JBODs to scale up disks, as we've mentioned. But you called out a couple of things before around how our Hyper-V cluster connects to the back-end storage, the scale-out file server that we've defined. Is it just 1 gig networking? Is it 10? Is it specialized? So talk us through some of the design considerations that people will be making around that.
That's part of the conversation. That's part of the conversation. You can absolutely use 1 gig networking if that's all you need. So a 1 gig interface will give you about 110 megabytes a second. And you can do the math and see how many 8K IOs you get out of this. And if that's all you need, then that's great.
All you need.
We will probably suggest that you use 2 for high availability fault tolerance, and maybe even 3, 4. I saw someone that did 6 times 1 gig in a configuration. Multi-channel can handle that just fine. Now, 10 gig is becoming more and more popular. And at 10 gig, we have that RDMA option that we talked about, where you can actually offload the transfer of data and get lower CPU utilization, higher throughput. So that's something people are looking at. And then you can go higher, you can go 40, but 2 times 10, 4 times 10 is really a lot of throughput. And the CPS solution that we have, that Sid talked about, uses multiple 10 gig interfaces. That's a great solution, even at high scale.
Yep.
If you want to go wild, 40 is out there, and there's multiple solutions that you can grab. Multiple vendors offer 40 gig at this point.
So 40 gig, 56, and I guess is 100 on the horizon, or is it already available?
We might touch on that.
We might touch on that. All right.
Add a couple of
there you
things.
go.
I mean, if you think about the high-speed SMB3 storage network fabric, that's essentially analogous to a fiber channel SAN fabric or a iSCSI SAN fabric as well. And like any fabric, it provides, resiliency, as kind of Jose mentioned, by giving something what we call SMB multi-channel. It kind of protects against path failures.
Yep.
It gives you highly available file shares through SMB continuous availability. So when basically one node dies, the SMB session transfers automatically and transparently without any interruption of service to the VHD.
Right.
That's number 2. And thirdly is SMB Direct with RDMA, where we basically are having very low latency data transfers. So what it does, initially it sets up the connection, then it completely bypasses the TCP stack.
Right.
And we've kind of measured the effectiveness there in what we call cycles per byte, where less cycles per byte is better so that you don't burden the host. And our goal is to make sure the Hyper-V hosts as much VMs as possible. And it's not dedicated to kind of processing the I/O traffic there. So those were some of the things we kind of kept in mind here.
Excellent. Excuse me. And we'll come back to that a bit later on, I think.
Okay.
So let's talk about some of the other new things that have been announced as part of the conference. With the architecture that I've kind of prescriptively described there is around JBOD, external to the nodes. So the nodes are very light in terms of local storage.
Yes.
But all of the disks are contained within this external JBOD. SAS connectivity from there. I believe there's a new deployment architecture option. How would you tell us more about that?
Yeah, so we announced something. We are super excited to announce something called Storage Spaces Direct.
Right.
Okay. What that essentially means is now we are able to take regular servers, okay, and just aggregate the storage drives within the servers and present the same goodness of storage spaces.
Right.
So basically what it means is you don't need the shared SAS fabric with the shared JBOD at the back. So we heard a lot of feedback from customers that, hey, give me another option where basically I can have more fine-grained scaling. So let me talk about a few benefits of Storage Spaces Direct. So it kind of, what you're doing now is instead of the data going through the shared SAS fabric, now those storage server nodes are using a high-speed SMB connection. So what Storage Spaces is doing essentially is taking your devices that are inherently unshareable, like think about it like non-volatile memory.
Yep.
It's kind of always scoped to a single server, or like SATA SSDs. And these are low-cost, price performance, devices. And we want to kind of take that. SMB takes those devices, makes it, part of the logical scale-out pool of storage and prevents it, right?
Yeah.
And we are doing this. This is not a new architecture. It layers on top of the existing Spaces architecture.
Yep.
So all the goodness of Spaces that you have seen in 2012 R2 carries forward.
Right.
All we're doing is kind of removing the SAS fabric in the back.
Gotcha.
One thing that's interesting is that everything you learn, how to create pools, how to actually turn them into virtual disks, that all continues to apply. I like to say, for instance, that if you have a solution where you have 4 machines, each one of these 4 machines has, say, 4 disks. So you put these machines together, you turn on Storage Spaces Direct, and each one of the 4 machines sees 16 disks. Right. They see each other's disks. And they really can't tell that these are not right there inside the machine. They really see 16 disks that I can go and create a pool out of. And that's basically what Storage Spaces Direct's magic is. It's a layer of software that goes and says, okay, everything that's inside this machine will be shared with the other peers in the cluster in terms of storage. Yep. And that includes things that were not designed to be shared on the hardware layer, like SATA, like NVMe. But then when you turn this on, the layer of software makes it shareable.
Yeah.
And then you can go and create pools and create clusters, all that. So that's basically what we're doing.
Magic going
on. I want to just add one more thing there. I think by being able to scale one server at a time, it gives you finer grained expansion, right? In terms of both IOPS and capacity. That's kind of one. We also announced a lot of partners, our server partners, basically 7 of them, as initial development partners for Storage Spaces Direct. And one more thing I just want to call out, it has 2 deployment modes, basically. One is traditionally where we see compute and storage being disaggregated or separate, which enables independent scaling of compute, independent scaling of storage. So you have your Hyper-V cluster tier, and then you have your separate storage tier, right, with shared nothing storage or Storage Spaces Direct. Now, for certain types of deployments or certain types of workloads, you could also collapse that together and basically have your compute, storage, and network co-located, what we call hyper-converged. I mean, the industry calls it also hyper-converged. So we offer you the flexibility with Storage Spaces Direct on choosing what you need. I mean, either you have disaggregated storage and compute, or you have hyper-converged storage and compute.
And you'll still be able to do the old model as well.
Yes, and we support the old model as well. So we really have our offering a choice to customers depending on what workloads, segments they need. They have the choice of deploying what they want.
And this shows up. If you look at the hyper-converged, right, what basically happens is instead of 2 clusters, you have 1. And in that cluster, you can do the sharing of this that we were just talking about, and you refer to it as a cluster shared volume path. So it's C column, cluster storage, volume X. And that's basically how you use it. You don't see the remote path, but there's communication happening between the machines. And the whole notion is to keep it simple, keep it familiar, but at the same time giving you these new hardware deployment options that we didn't have before.
Yeah, nice. And all of that can be configured by PowerShell. All of that can be configured through, I guess, System Center as well.
Absolutely. It's PowerShell and SCVMM and SCOM, so we have a great management story there as well.
Now, there's been a few announcements this week, outside of storage specifically, one of which being Nano Server. Quite a lot of interest in that. Will this technology, the Storage Spaces Direct and storage in general, is Nano a candidate for being a scale-out file server node?
Absolutely.
Even the Direct?
Even the Direct, yeah. So basically, I think if you see it, Nano is going to be the installation option for the storage fabric and the compute and network fabric. So everything we do in our teams, scale-out file server, Storage Spaces Direct, everything is going to be available on Nano.
Okay.
And the teams are working very closely to make sure we have a solid offering for customers.
Excellent. Okay, great. So I wanted to potentially change direction a little bit and focus on some of the other areas of the stack within the storage specifically. Before I do you want to walk us through something that's quite exciting around the RDMA side of things?
Yeah, so we actually did a demo, and I like that because it was the closing demo for the talk that we did on the storage overview. And that demo showed how we can use the latest technology. Because people are always saying, oh, there's some new stuff happening in Flash, there's some new stuff happening in networking. Can your stack keep up?
Yeah.
Right? And I always like to say, we feel very comfortable there, but people want to see it in action. Right? So we showed something, and if we could switch to the demo machine here.
Yep, we're on.
What you basically see here is we have a solution that shows a configuration with just three NVMe devices remotely accessed through a 100 gigabit Ethernet connection. And that, what you see here is we're doing 11.1 gigabytes a second. That's 10 times 10 gigabits on a single port of a single network interface, right? We're also doing this with very low latency, so these are 64K IOs with 1 millisecond latency remotely, and we're doing this using less than 15% of the CPU of the machine.
Right, so to clarify for people as well, these are NVMe SSDs specifically.
Just three of them.
Three of them at the back end. You've got a special adapter, network adapter that's RDMA capable that you're using to connect to that.
Just one port of 100 gig.
And it's going at 11 gig a second data transfer rate.
Yes.
11 gigabytes.
Yes.
Yeah.
It just sounds a little bit slow to me, guys.
And that's pretty much line rate at 100 gig.
Yeah.
Right? So we're doing well there, and
right.
You can see the CPU utilization is very low. So there's room to run your workload in addition to that. But people sometimes ask, what would happen if we didn't have RDMA, right? And that's what this demo, which we didn't have a chance to show, can demonstrate. So I have a command here that can disable the RDMA stack, and then we turn back to TCP/IP. And then the interesting thing is to go and watch first of all, SMB will survive that event just fine,
Yeah.
right? And will continue the workload. But what you see is, without RDMA, we switch back to TCP/IP. And then our performance dropped without RDMA to 5.7.
Only 5.7 though, yeah, but still
Only, which is
still significantly
not
less
a,
though.
not a bad performance at all.
I can
But
copy my
our
photos
latency
around incredibly quickly.
doubled from 1 to 2 milliseconds.
Yeah.
Which, not bad, but it's twice the latency. Our CPU utilization shot up though.
Right.
And that's what the problem is. Because when we are doing this, basically what happens is we go up to 20% to do just 5.7 gigabytes, which is about half of what we're doing before, because TCP/IP we create multiple connections, but these connections affinitize with specific cores. So if you look at our CPU here, you see that there are 4 of these cores that are pegged
Yep.
at 100%. And that's exactly what we expect, right? You start creating TCP connections, you try to do as much as you can, but although you have 28 cores here, you can't really engage all of them. We could actually tweak the configuration and probably get the full bandwidth, but then we'll be using a lot more of the CPU.
More CPU.
So RDMA is all about saving the CPU cycles and giving you great throughput. So that was an interesting demo that we didn't have a chance to show.
Oh, great. There you go. Exclusive for you now. Here we're on Channel 9. Those kind of cards, are they mainstream yet? Are we seeing more and more of those kind of specialized cards ship in today's servers? Should people be asking them on their shopping lists?
100 gig is still, 100 gig is just getting announced.
Right.
I think the point of the demo here was to show, hey,
the impact of RDMA.
The impact of RDMA, right? So right now, we have 40 gig, but if you see 100 gig, which is going to first start in the data center and then kind of branch out, I think the point of the demo is to show that, when we are trying to ship data, think of the world as a lot of large number of nodes. They're having SATA, SSDs, and hard drives and NVMEs, and we can ship data very fast.
Yep.
And make sure that the data serving back to the Hyper-V cluster or the app cluster is really optimal.
Okay, so we'll park scale-out file server there for now, and some of the spaces in RDMA, and change direction slightly to focus on quality of service and how I can avoid that noisy neighbor type experience within a virtualized infrastructure, particularly around storage. Explain to us a bit about QoS.
So one of the feedback we heard from customers is, hey, give me some way to regulate and monitor and control performance. So if I have a rogue VM in my data center, accidentally had some virus injected or it's intentional, that could basically take away IOPS from the large collective pool of data center IOPS. And there is pretty limited actions you can take today. We have a lot of great things in 2012 R2, but I think we took that one step further and made it really, at a level where across the Hyper-V cluster and the storage cluster, you can allocate min and max IOPS on a per VHD, per VM, or a group of VM, or a service basis. It's very flexible. So basically what that means is you can kind of put caps on the types of VM where you think there should be caps, and in other cases, you want to allocate more maxes. For example, your SQL log VHD hanging off your SQL VM, you might want to have a faster IOPS and a higher IOPS bar there. So that was very effective in kind of throttling the overall, traffic and shaping the traffic in the data center.
And it's important also to have the ability to monitor, right?
Yep.
Today, if you have, say, 10, 20 Hyper-V hosts running a few hundred, maybe even a few thousand virtual machines, how do you look at performance today? When you look at performance, you basically think, okay, I have to go hook up performance monitoring in all these places. What this is also is an infrastructure to gather information from all the hosts, from all the VMs, put this in one place which is called the policy manager. And you can use a simple command to just go say, okay, give me all the VMs. Sort by the number of IOPS that each VM is using. Even if you don't apply any policy at all, just having that information is a great thing. And then with that, I can see, which host has the most VMs doing this, or which storage node, and it gives you one command to kind of understand the whole thing that's happening. If you're an Excel person, you can actually export that and start doing pivot tables with your storage performance, which I think it's the peak
powerful.
of geekdom, right? It's in
absolutely, yeah. Pivot table on your IOPS, excellent. Now, if we think about QoS and actually go back to what we talked about before with storage spaces direct, are these technologies compatible or is it something we should keep external to one another?
Well, they all work together.
Right.
Everything we are doing, obviously, customers will put that together, and we're kind of making sure they all work together. So storage spaces direct and storage cores absolutely work together very
Okay,
well.
great. And when
And not only that, I mean, you can live migrate VMs, and the quads will follow, the policies will follow the VM. You can actually do everything we talk about, multi-channel. Together with this, the fault tolerance is there, you lose an individual node. So this is designed to work as a solution. And this is also being managed by VMM. So you can use VMM to create the policies, to apply the policies to the virtual machine. So it's an integrated solution.
Yeah, so nice for the admin to be able to control that, but also have the flexibility if they want to do it with PowerShell as well.
Yep,
so it's
absolutely
very straightforward. Now, when we think about protecting our infrastructure, we want to make sure that we can protect data that's important, our virtual machines, our workloads, our SQL data, and so on. Hyper-V Replica has been around for a while.
Yep.
In terms of replicating virtual machines, their virtual disks from one place to another, either another on-premises location or Azure. But there's been some innovation in the storage stack that gives us new options for replication of data. Tell us a bit about that.
So, sure thing. So Hyper-V Replica today, offers a great service in terms of, doing VM-level replication. We heard some feedback that, hey, give me some level of replication, especially synchronous replication, where basically with zero data loss, I can replicate large volumes. We kind of took that to heart. And one of the main reasons is if you look at a storage stack, the replication solutions basically, and storage overall is very expensive. So we're trying to kind of democratize the storage replication market, if you will. So basically, we announced also Storage Replica. What that does effectively is it does synchronous replication of any storage volume. Okay, it could be a spaces volume, a spaces direct volume. It could be any SAN or NAS volume, partner SAN or NAS volume, okay? And it operates in two modes. The synchronous mode, basically it takes the volume, and whenever you're writing a byte to the local volume, it writes it to the remote volume. All we ask for, you have a less than 5 millisecond latency link between the two volumes, could be across the river. So what happens essentially is when you're doing that, we can deploy this in what we call a stretch cluster mode, where you have, let's say, 7 nodes, 3 nodes in one location, 4 nodes in another, each with its own shared storage. They're doing replication. If one site has a disaster, the other site takes over, keeps on operating. That's like one stretch cluster. And you can also deploy this in a cluster-to-cluster configuration. We have 2 discrete clusters, and they can be replicating data between the two. So all in all, it was kind of enables business continuance and DR for the masses, if you will.
Yep.
And you can use this with your existing, SAN infrastructure.
Okay, so if you've made the investment already,
yes,
that's good.
Yeah.
And that's a good segue actually, because there's a lot of management integration that we've made in previous versions of System Center, for instance, to help us integrate and manage SANs, provision LUNs to hosts, whether they're SMB based from some of our storage vendors who support SMB, or whether they're native fiber channel or iSCSI. So there's certainly a lot of work going on with our SAN vendors as well.
Yes.
Now, before we wrap up, are there any other sessions this week that you've delivered that you would recommend to people watching at home?
Oh, absolutely. I think we have a ton of sessions today.
Right. You're not supposed to be there now, are you?
No, I'm not supposed to be. So we had the storage strategy session, which Jose and I delivered on Tuesday. We had a bunch of great sessions on Azure consistent blob storage, storage quads, basically yesterday.
Mm-hmm. Yeah, but today there's one on Source Spaces Direct.
Oh, right, great.
Must see.
We have Storage Replica.
Yeah, Replica is at 5 today.
We have a bunch of sessions
today,
so go and check them out. Yep.
Excellent. Well, that's all we've got time for. Thank you very much for joining us. Thanks to the team for joining us and giving us some insight into storage, doing an exclusive demo. Don't say we don't do anything for you. Next, we're going to the live stream in a hot room where you're going to learn all about the advanced Windows defense with Erdl. So definitely stay tuned for that. Thanks for joining us. Enjoy.
Thank you.
Thanks.